Auzubillahiminasyaitonirrajim. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh, and a very good day to everyone. This is MKG4033, Introduction of Fuzzy Set Theory, and our group will handle case study 26, which is Fuzzy Complex Queries of Database of Small Manufacturing Companies. These are the members of our group: Sofitra, Lo Jiying, Wong Shiuli, Zubair, it's me, Adam, Izzat Izran, and Ayu Nazira. So we'll jump into the introduction of this case study 26. Fuzzy logic uses approximate rather than exact reasoning to solve issues in a manner similar to human logic. Fuzzy queries of this sort can be utilized as a decision aid in a variety of business, financial, and management operations. Small businesses, stocks, and mutual funds are among the applications. Uncertainty and fuzziness, on the other hand, are inherent in the data in many sophisticated database applications, particularly spatiotemporal database systems. Because of the nature of the data, in these complex spatiotemporal applications, there is always a requirement to provide flexible searches and analysis of uncertain and fuzzy data.
Today I will show you how we take this database and change it to fuzzy sets. So let's look at these data sets. So this data sets contain of company, age, annual revenue, product count, employee count, profits, and earning per share. And there are 12 company in here. And for this data, there are one that is script set, that is company. And the another 6 one, which is this one, is a fuzzy set. So let us know what is script set and fuzzy set. Script set is, as we can know, the member of each function can be X, can be in 0 or 1. So it means that in this core company, there must be 1 or 0 only. There must not be 0.1 or 0.2 and another thing. So for company at here, we only count the company that exists. That means that all company is script set is equal to 1. So if we draw the graph will gonna be like 3. Everything will be at 1 like that. So because we do not include it with the company that not exist anymore. So but here we only focus on the fuzzy set, which is age, annual revenue, product count, employee count, profit, and earnings share to gain our goal. So that looks at the age fuzzy set. So this is the fuzzy set table for age. This is fuzzy set table for company age, and we can see that the member peak function is between 0 and 1. And from here, we by using this fuzzy set, we can look at all of the company age, and we can see how it's moved. And here we can see a triangle fuzzy sets, and trapezium fuzzy set here. And this is for the triangles. So let's look at the annual revenue. So this set also contains between triangle fuzzy set, which is this one triangle fuzzy set, this one also triangle fuzzy set, this one, and this one also triangle fuzzy sets. And this one is a trapezoidal fuzzy set. And we can look at here to calculate all and make all conclusion about the total revenue of the company. And this is fuzzy set for product count, and we can look the trend of this graph, and this was divided into 3 classes, which is few, some, or many, or it can be low, medium, on high. And this consists of 2 trapezium fuzzy set and Y triangle fuzzy set. And this is fuzzy set for employee count. This employee count, we can here we can see that this is trapezoidal fuzzy sets, and here is the triangle fuzzy set, here and here is triangle fuzzy sets. So from here, we can see that we can make a conclusion all about the employee count by looking at this graph and find the U at this point, where the intersection point like here, 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 and calculate it. Okay. And here is the fuzzy set in terms of profit for negative profit, which is loss. So here it consists between negative 40 until 40. So we can look the graph, how it's made on this graph, and the highest is 1, following our fuzzy set definition. Okay, so now I will explain one of the graphs to tell. So in this company H, so we can see there are new, measure, established, and old. And at the where when the company just built, so it was in this new one. And at this point, the company begin to be a little bit new and a little bit matures and into the mature phase. So at this point, the company start to go the mature phase. So this will be the mature phase, and is like same for other thing. At the half is the phase that they are entering to new phase, and we can see at the company that are in old one start at here. So the company which are really old is calculate at x equal to here, and so on. Okay, so that's all from me. I hope you guys can understand how we change from this data set into all the fuzzy set that we create that must have membership function, and it was a partial membership functions. Okay, that's all from me. Thank you.
For query 1, let's consider the companies by using the database in table with the company's name C1 to C12 and 6 attributes involved, as well as H stand for company age, AR stand for annual revenue, PC stand for product count, EC stand for employee count, PR stand for profit, and EPS stand for earning per share. These are the 12 companies in the table named by C1 to C12. The query is, we need to select the company where the age is mature, the annual revenue is high, the product count is some, the employee count is moderate, the profit is moderate, and the earning per share is good. In this query, all 6 attributes are involved, so we have to repeat 6 times the matching procedure. This will give the degree of membership of each entry in every fuzzy set of the query, which belongs to an appropriate attribute. And these are the terms for each attribute. This is the terms of company age. This is the terms of annual revenues. This is the terms of product count. This is the terms of employee count. This is the terms of profit. If negative profit is lost, while if positive profit is earned. And lastly, this is the terms of earnings per share. Now we look at the terms of company age. For instance, the term mature from the company age is described by a triangular number on the supporting interval 5 to 20. By referring to the table, the values of 8, 12, 16, and 17 of the domain of age, which belong to the interval 5 to 20, have to be matched against the term mature. So they will have the degree of membership in the term mature, and it was recorded. The other values of the domain of age, such as 44, 42, 34, and 26, are not in the interval 5 to 20, so they have 0 degree of membership in the term nurtured. After this, the same procedure is applied to the other 5 attributes, where it is high annual revenue, some product count, moderate employee count, moderate profit, and good in earning per share. We need to construct a table to record all the degree of membership for each term. Then, all the attributes in the query are connected by A and B, and where we need to find the minimum of the degree for each row. Now, let's look at the table that records all the degree of membership for each term. Most of the companies, except of C8 and C9, all have at least one data zero in its row. Hence, the outcome of the mean operation is also zero. For example, the company C3 has the minimum degree, which is 0 in its row. So, the end value for it is 0, same as C1, C2, C4, C5, C6, C7, C10, C11, C12, except of C8 and C9. While for C8, the minimum degree is 0.125, and for C9, the minimum degree is 0.2. Last and foremost, let's use the averaging instead of the minimum of the degree to connect all the attributes and record the result too. For example, the company C3 has the average of all degrees in its row, 0.28. For company C8 is 0.65, while for C9 is 0.56. The averaging is get by adding the 6 data of the same row dividing by the sum of 6, where the 6 data came from 6 different attributes, and each row came from each company. That's all for query 1.
For this slide, I will explain about the query 2. For query 2, select name from company where age is mature, or annual revenue are high, or product count is some, or employee count is moderate, or profit is moderate, or earning per share is good. This is the graph of term of company age, term of annual revenue, term of product count, term of employee count, term of profit negative profit is loss, and term of earning per share. The query formula can be obtained from query 1 by changing and by or. Hence, now the attributes are connected by or max. For company C3 in this table, for instance, we get max 0, 1, 0, 0, 0.2 and 0.5 equals to 0.5. For C8, max 0.4, 0.125, 1, 0.9, 1 and 0.5 equals to 1. The result for all companies are given in the last column or in this table.
In query 3, it does not involve all attributes in the database. From the table, only the column labeled DMA, H, and DG we use to find the membership degree in the conclusion N. Then, we have to select the name from company where the age is mature, the annual revenue are high, and the earning per share is good. For the age to be mature, it has the range in between 5 to 20. For annual revenue is high, it has the range in between 100 to 110. Last, the earning per share is good, has the range in between 2 to 6. For conclusion N, it means that we have to consider the minimum number among DMA, H, and DG. The result of conclusion N of each company have been shown in the table. For company 1 to company 7, they have come up the result 0 as their minimum number of conclusion n. But for company 8 and 9, they have another minimum number of conclusion n. That is 0.125 and 0.2 respectively. Then the last three company 10, company 11 and company 12 also have the same result with company 1 to company 7. That is 0 as they are the result of n.
For this slide, I will explain about query 4. We have to select name from company where age is measured and annual revenue are high, or employee count is moderate and earning per share is good. The result from company 1 to 4 and company 11 and 12 is 0, while the company 5 and company 10 is 0.25 respectively. Company 6, company 7, company 8, company 9, and company 10 is 0.1, 0.2, 0.5, 0.75 and 0.25 respectively. Is being shown about in the table below.
In conclusion, case study 26 demonstrates the advantage of fuzzy queries over standard queries in the context of database of small manufacturing companies. The case study shows that fuzzy queries can be used to retrieve more relevant results and that they can be used to express more complex queries. The case study also shows that fuzzy queries can be used to retrieve results that are ranked according to their relevance to the query. This is important because it allows users to quickly find the most relevant results. Overall, case study 26 demonstrates that fuzzy queries can be a valuable tool for retrieving information from database. They can be used to express more complex queries and they can be used to retrieve more relevant results.